Tiffany Arielle here, and we are continuing the Learn to Code series. So today we are going to be working on the same assignment that we were working on before with the Stanford Karel. So if you have not already, please go back and check the playlist, which I'll have in the cards. You'll definitely need to go through that first video and make sure you have all this setup done. And you may want to look at least the first part of the second video where I explain Karel and what she can do and what she can't do. Outside of that, you don't really have to do these videos in order. So I'm going to get into the video for today. Okay, so we got our screen recording going. So like I mentioned before, we are going to be doing the same assignment that we were already in. So now we are on problem 3, which is StoneMasonKarel. So it says our third task is to repair the damage done to the main quad, which is a portion of Stanford campus, in the 1989 Loma Prieta earthquake. In particular, Karel should repair a set of arches where some of the stones, represented by beepers, of course, are missing from the column supporting the arches as illustrated in the figure below. Okay, so what they're saying is basically, I guess we have to fill in each of these columns with the rest of the stones. So it should be a stone here, 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 also here, here, etc., right? Okay, it says our program should work on the world shown above, but it should be general enough to handle any world that meets the basic conditions outlined at the end of this problem. There are several example worlds in the starter folder, and your program should work correctly in all of them. When Karel is done, the missing stones in the column should be replaced by beepers so that the final picture resulting from the initial world would look like the illustration below. So yeah, as we were saying, we got to fill in everything. Okay, it says Karel's final location and the final direction Karel is facing at the end of the run do not matter. Karel may count on the following facts about the world. Okay, so once again, they're giving us some things that we can assume to make our lives easier throughout this process. So it's saying Karel starts at the corner where 1st Avenue and 1st Street meet, facing east with an infinite number of beepers in Karel's beeper bag. Okay, so let's break this down. So basically it's saying Karel starts here at 1-1. It's facing east, which is to the right. And she has an infinite number of beepers. So we talked about, I think in the last video, that, bad things can happen if Karel does not have enough beepers and then she tries to put them down, program will crash. Okay, first column should be built on 1st Avenue. Okay, so it's telling us that the first column is always going to be this very first column. So we know that the first column is always going to be here. We don't have to try to go find the first column. Then it says the columns are always exactly 4 avenues apart. So they will be built on 1st Avenue, 5th Avenue, 9th Avenue, and so on. Okay, so that makes it easier. So we know where all the columns are. We know that we're always going to do 1, 5, 9, 13, 17, whatever. Okay. The final column will always have a wall immediately after it. Okay. So if you remember the last one, we did have like similar types of thought processes. So you probably are already kind of familiar with why these things are important. Because one thing here, it's telling us we always start on the first column because where do we start is always important. We had a move to next a function. So here we'll probably also have a move to next function. So in order to move to the next, we're going to need to know how far apart are the columns, telling us the final column will always stop. So this is very important also because when you have a problem where you have kind of a general situation where you're like, I have no idea how big this world is, you're probably going to have some sort of loop and you need to be able to say, when do I stop? So in this case, similar to the last case, we stop once we've reached a wall pretty much. It says, although this wall appears after 13th Avenue in the example feature, your program should work for any number of beeper columns. Okay, then it says the top of a beeper column will always be marked by a wall. However, Karel cannot assume that the columns are always 5 units high or even that all columns within a world are the same height. Okay, so similar situation here. It's telling us that there's always going to be a wall here, but this one may stop at 3 and then this one could be 5 and this one could be 1 or whatever. We don't know how tall they are. Okay, then it says, in an additional world, some columns may already contain beepers representing stones that are still in place. Your program should not put a second beeper on corners that already have beepers. Avenues that will not have columns will never contain existing beepers. Okay, cool. So basically what this is saying is that we don't have to worry about like picking up beepers in these other columns. So we don't have to worry about that. And then it gives us some worlds to try. Stonemason Karel, sample quad 1, sample quad 2, and all the worlds are there. Okay, let's get started. Let's open our PyCharm. Should be this one. Okay, so this is where we are. So yeah, we do see the StoneMasonKarel. We do see sample quad 1 and sample quad 2. Okay, but we don't have a StoneMasonKarel.py. So once again, we are going to copy, Command C, and then Command V, and I have StoneMasonKarel.py. And we click OK. Okay, so now we have our template. So let's go back to our assignment. Actually, before we do that, let me go ahead and put the world here. Can I copy this? Copy. Paste. Oh. Okay. Okay. So that's the first world that we're going to run. So before we start, let's go ahead and just run StoneMasonKarel, because we're just going to make sure we have the right world. Okay, cool. So we got the world running, so that's good. Now if I click run program, it does nothing, which makes sense. So we're at a good starting point. Okay, so now what do we have to do? This is the situation that we're in. We have to fill in all the columns. So what do we know? We know that we need to fill up a column. We know that we need to move to the next column, and we need to know when to stop. So let's just, for now, let's just worry about the first column. So let's say, how do we fill one column? So I'm going to write a function fill column because I know I'm going to need to do this multiple times. Now it's red because, of course, I haven't defined this function. So let's go ahead and do that the same as before. We have def fill underscore column, colon. So now our function is defined. So how do we film a column? So they told us that Karel is always going to be here facing east. So I know that in order to film the column, I have to go up. So I said, okay, I have to go up. So that means I need to turn left because obviously I can't go up if I'm facing to the right. So then I need to put beepers on every space until I reach a wall because they told us that the top of the column is going to have a wall. So let's do this. So we have till we reach a wall. So that would be while front is clear. Basically, I need to put a beeper. Okay, let's try this out. Let's see if this works. Run. Oh, snap. This is bad. It's going forever. Oh my God. Okay, let me close it. So key thing here, what happened here is that we created an infinite loop. That program was never going to stop running because as you could see, Karel it didn't move anywhere. It said, oh, while front is clear, let's put down a beeper, but I never moved. And so if there's no wall immediately in front of me, a wall is not going to magically appear. And I did not do this on purpose. Like I literally just made this mistake because I wasn't thinking. So we know that we need to put down a beeper and then we need to move to the next step. So let's make that change. We click move. So normally you always need to make sure that you know how to manually stop a program in case you accidentally create an infinite loop. So here we have a graphical interface, so we could just close the interface and then it stops the program. Alternatively, I could have clicked the red square. It would have been red if this was running. I could have clicked that. Depending on what other code you're running, you could also type Control C or something if you ran it from the command line. But that is just generally something that you always need to make sure that you know how to do because it's very common to accidentally create infinite loops. So let's start this again. Let's try now. Okay, we put down a beeper, we move, we put down a beeper. Okay, that's not what I wanted. Because I actually have two beepers here, so that's definitely not what I wanted. So there's something wrong, but I guess we can fix that. We can say if no beepers present, put beeper. Okay, let's see if this works now. Also, if you forgot what Karel knows how to do, we have on this reference guide. So we checked here, we're using the front is clear, saying beepers present, no beepers present, right? This is the one that I'm using right now, is the no beepers present. So let's go back to here. Let's try again. Run program. Okay, this looks better. Cool. But one thing though is that I don't know if you guys remembered in the last case. Let me actually show you. Let me change it back to how it was for a second, because there was something that happened that I forgot to mention. So I don't know if you can tell, but you can see that there's a 2 here. I don't see a 2 on this space. So what that's telling me is that it didn't try to put a beeper here. So we actually had 2 issues. So just now I fixed the issue where we had 2 here, but I didn't fix the issue where it didn't try to put a beeper here. So I'm actually gonna try to fix this one first, and then I'll go back and remake the change that I just made. So, because it looks like it's not working. So we had a similar issue the last time, where basically once I got to a point where I hit a wall, I didn't put down the beeper. So I missed the last one. So the fix that we had the last time, which applies here, is to go ahead and put down the beeper before we check if the wall is there. And then if you remember from the last time, we had an issue where if we did it like this, we ended up with 2 beepers on the front space. So we're not going to do that. So we have to rearrange these. Okay, so now I'm fixing that issue. The issue with 2 beepers should still be there, but we're just going to run this just to be sure. So you see I'm clicking the X, and then I'm going to start it again. Okay, so now it's really hard to see, but you can see that there's kind of a number inside of here. So that's good. So at least we fixed that issue. So now let's fix the initial issue that we had already fixed. So basically the answer was, we said if no beepers present, then we put a beeper. And of course we have to do the same thing here as well. Okay, cool. So let's save this and let's see if this works now. Okay, cool. So this seems like it's working. Okay, so we got our fill column. So now what do we have to do? We need to move to next. So how do I move to the next column? Let's look at the picture. So right now I'm up here. How do I move to the next column? Now you might say, oh, you can just walk across here and then go down, which that would work if the columns were always guaranteed to be the same height. But they told us that they're not always going to be the same height. So I can't just walk across because I don't know if this other column is going to start down here or up here. I don't know. So what I think is the best thing to do is to actually just go back down to the start and then move to the next column. So that's what we're going to do. So right now we're up here, we're facing kind of up. So in order to go down, we need to turn around. So let's turn around. We have def move to next. Okay, so we said we need to turn around. And then after we turn around, what do we need to do? We need to move back to the start. So how do we do that? Let's write a move to wall function. So we're going to just move to wall. And then after I move to the wall, I would be facing down. So then I would need to turn left, I'm pretty sure. So if I'm facing down and I want to be facing right, yeah, I need to turn left. So I'll turn left. And then they told me how many far apart. They said they're 4, so 4 columns apart. So then I would need to move 4 spaces. So I can do move 1, 2, 3, 4. Okay, so it's telling me I don't have a turn around or a move to wall. So let's go ahead and write those. So we have def turn around. Now I think we already wrote this before, but I'm not going to go back and do it. Basically, before we decided that we could turn around by turning left 2 times. If you don't remember why we decided to turn left instead of turning right, it's because turning right is just a combination of turning left. So if we said turn right 2 times, that would be actually turning left 6 times, which is worse than turning left twice. Just a little bit of a refresher. And then we have, oops, how did I end up in caps lock? Def, move to wall. And how do we move to wall? I don't think we've done this before, so let's go back and look at our reference guide. So, okay, I have move, turn left, blah, blah. So how do I know if I hit a wall? I know that I've hit a wall when my front is clear. So let's do this. While front is clear, move. Seems reasonable, right? I think this should work. I don't see any red letters or anything like that. So let's see if this worked. So we run the program. We're filling up the column like we did before. We turned around. We went back to the bottom. We turned. We walked 4 steps. And yeah, we're good. We moved to the next column. Okay, so that should be good. So now basically all we need to do is just repeat this process until we are finished. So how did they tell us that we're finished? They said that basically if there's a wall after my column, then I am done. So when should I check if there's a wall? Let's see. So let's say okay, so I guess I could just say while front is clear, oops, fill column, and then move to next. That might work, right? We said we have to keep going until we hit a wall, so we'll just say, oh, while front is clear, we go, right? Seems reasonable. Okay, seems like it's working so far. Oh, that's not good. Notice we didn't do the last column. This is the same issue we had up here where we didn't do the last beeper. So how did we fix that? We said, oh, I need to put down the beeper before I check if the front is clear. So we need to do the same thing here. We need to fill the column before we check. And then since we moved that outside, we move this to the end because we don't want to fill the column and then try to fill the same column again because that makes no sense. So let's stop this. Let's see if this works now. Oh, that's bad. Okay, so that didn't work either. So now I'm looking over here. So it looks like I need to try to, I don't know. What's the problem? Okay, so I filmed the column. So this is what happened, right? I filmed the column. When I filled the column, this is where I stopped. I said, while front is clear. But guess what? There's a wall in front of me. That doesn't work. So I need to go back to the bottom and then check if there's a wall in front of me. So let's try this too. Maybe we need to move to next also before we try to check, right? So let's try this. Maybe this will work. Let's stop this. Let's play again to run the program. Okay, this seems better. So far, so good. Oh, but we're still having the same issue we had before where we didn't do the last column. What is the problem? Okay, you know what? I know what we need to do. What's happening now is it's checking. So I'm trying to film, wait, hold on, where am I? So I'm filling the column, I'm moving to the next, but this is actually the same issue that I had the first time. So that's why this doesn't work. Okay, so what we need to do actually is we don't need to check in between these steps. What we actually need to do is we need to fill the column, then in the middle of returning to the start, so as soon as we get back down to the bottom, that's when we check if we should walk forward or not. We don't wait until after I've taken the 4 steps to check. That's why this isn't working. So we're going to keep this like this because there could be a situation where we have only like one column like this. I'm going to set next equals true. Actually, we're going to do this. We're going to set a flag. We did this in a previous one. So we're going to set a flag. We're going to say next equals move to next, right? So now within this move to next function, what we're going to do is we're just going to check. Let me think of the best way to do this. So basically we need to take 4 steps, but we only want to take 4 steps if the front is clear. Now, what they told us is that there will always be a wall right after the column. That's where this becomes useful, right? Because in this case, if there was a wall, let's say like here, like after 2, then what could happen is I might take 1 step and then be like, oh, I ran into a wall. So basically, in that case, I would need to check after every step, can I take another step? But because they told us that there will always be a wall immediately after the last column, all I have to do is as soon as I get to the bottom, check if there's a wall. So here, I'm just going to say if front is clear, then I know that I should be good. I know I need to do another column because they told us that in the assignment. And now if there's not another column, actually we're going to do the same thing as before. So if my front was clear, then I take my 4 steps and then I can return true. This is the same thing we did in the previous video. I returned true, basically saying I was successfully able to move to the next column. If I wasn't able to do that, then I return false. Oh. So over here, we say we have next equals move to next, but notice this is gray. So this is gray because I'm not using this. So I'm just going to say, instead of saying while front is clear, I'm just going to say while next. And of course, this one also needs to do this. So let's see if this works. Let's try. Let's play. Run program. Okay, well, we didn't break that, so that's good. That's one thing you always have to be mindful of, is that once you try to fix one thing, that you don't break something else. So we actually got into the last column. This is the first time we've done this. And we're good. Yes, success. Okay, so let's close this. So let's try the other worlds that they told us. We have sample quad 1. Sample quad 1. Okay, let's run. Hey, okay, let's close this. We have sample quad 2. Ooh, yeah, see, this one looks different. You see, this stuff is like different heights and stuff like that. So yeah, this one is different. Let's see, did we do a good job? So far, so good. We handled that different height. Nice. Look at us, guys. We did it. We did it. So that is it for today. We do have a couple other videos in this series, at least one more. There might be two. I'm not quite sure. And then I may be doing other projects after this. So if you have specific ideas for coding exercises that you want to see here, definitely comment those down below. But in the meantime, don't forget to like, subscribe, and share with all your friends. And I'll see you guys next time. Bye.